Dear students, a problem from kinematics. There is a given graph which you can see on the left that is showing the variation of velocity versus displacement. You can see on the y-axis is plotted the velocity and on the x-axis we are plotting the displacement. Which one of the following graphs, which you can see here, show the variation of acceleration versus displacement? So I would like to encourage you to try to pause the video and try to solve this problem on your own. Okay, so I hope that you have got the correct answer. Let's try to discuss the solution. It's not one of the standard graphs that we have seen till now. Like it's not a displacement time graph or it's not a velocity time graph. So we have to derive certain, look at certain equations what we have in kinematics to see and make some conclusions regarding the slope of this line or, some other parameters. So see, I don't know whether the acceleration is constant or whether acceleration is varying. You can see here, acceleration is constant, acceleration is varying. All these possibilities are there. So in general, I know acceleration is nothing else but the instantaneous acceleration is the rate of change of velocity. Now here, I have the displacement with me. So if I have the displacement with me, I cannot make any conclusion of this graph unless displacement is introduced in this formula. So let me multiply by ds and divide by ds. That will never change the equation. The moment I get like this, I see that this will be the velocity, ds by dt, the rate of change of displacement is the velocity. And now you are making some sense. It's saying that the slope of the velocity velocity displacement graph. What does this left-hand side represent? It is the slope of the velocity displacement graph. So I'll write here, slope of the velocity displacement graph is actually the ratio of the acceleration and the velocity at that point. So at any point, if you draw a tangent and find out the slope, that slope will be equal to the ratio of the acceleration and velocity. And precisely here we have the acceleration only versus displacement. So now suppose I take this point. See, one thing is sure that this slope is negative. That is observed in the diagram. So I'll write here negative value because you don't have any values given here. So negative is equal to acceleration divided by velocity. So I will say at x naught equal to 0. Okay, I'll not say x not equal to 0. I'll say x equal to 0. Yahan pe x equal to 0 hai. So what is the value of the velocity? You can see that value of velocity is v naught. That is the maximum value of the velocity possible. You can see that's a maximum value. Therefore, acceleration will be, and it's maximum and it is positive also. You can see it's positive also. Now, negative into a positive value will be negative. So one thing is sure that acceleration is negative. So, and negative and what? Negative into v naught, that is the maximum value. So it will be at the negative maxima. So look at it. The only graph which is suiting this concept is this value. Look at this one. At x equal to 0, your acceleration is at negative maxima here. Now let's check this value if you still have a doubt. Now you can see that at x equal to x naught, what is the value of the velocity? It is 0. You can see here, velocity is 0. If velocity is 0, what is the value of acceleration? Negative, whatever slope is into 0, that will be 0. Is the acceleration 0? Yes, it is 0. And similarly, in between, the velocity keeps on decreasing. Okay, sorry, velocity is here. From here, v naught, it is decreasing. So as it is decreasing, the acceleration will also decrease. So all of these points are clubbing together and pointing that this is your correct answer. So I hope that you have, you have been able to identify the correct answer. Thank you so much for watching.